Welcome back to Armchair Architects as part of the Azure Essentials Show. So this is the second episode of our agent season, and this time we're going to take them apart. We're going to pick all the pieces apart. We're going to talk about what makes them. We're going to talk about what's essential when you're building them. We're going to talk about the knowledge and the orchestration and all the good stuff that you're going to know about when you're trying to figure out how to start building agents. So let's get right to it with our architects. Hey, welcome back. So last time we were talking about what an agent is, what an agent is not, and the obvious question that came up at the very end, which is like, okay, cool. Now that we have a sense of what this is, and if you haven't seen the first one, you should go back and watch it because it'll help a lot. Now is okay. I dig it. How do I build one? What's the anatomy? What are the things I have to have? How do I construct it? What do I have to pay attention to? And so I'm hoping in this episode we can take a moment to talk a little bit about that. So do either of you want to tell me a little bit about like how do I build one of these things, because they sound awfully cool? Like how do I get one for myself? So
I think Eric kind of rattled off in the first episode a whole bunch of capabilities that we already know we need. So the first ingredient, which we have talked about, is a language model. It doesn't have to be a large language model. It could be a small language model. It could be open source. It could be one of the frontier models, depending on what you need. But the first thing you have to have is a language model. Otherwise, it's not an agent in our sense, if you don't use a language model. You can use all sorts of other tools as well, but that's the core ingredient in a language model.
Right.
Then the second ingredient is ultimately knowledge. So I mentioned it in the last episode. Knowledge is what the system effectively uses to go and understand its world. Because what you're trying to do with a software agent, as opposed to a chat environment, you're effectively trying to constrain the system to what it's supposed to understand. And that's what we call knowledge. In the chat world, often this is equated to RAG. So the retrieval augmented generation is ultimately the knowledge you give, the real-time world you give to a chat system to contextualize the request. That's the same thing for a software agent or an AI agent, where you use knowledge. It could be a user manual, could be a Word document, a spreadsheet, or a database, whatever it is, where you have knowledge that this agent can use to go and reason over the event, the request, the ask, whatever it is that it's supposed to do, to develop the plan to execute. So knowledge is a key ingredient. The second thing that the third thing outside of the model that we see is a lot of capabilities around, how do we say this, orchestration. So one of the things that we are seeing is that people are using orchestration tools like LangChain, Semantic Kernel, AutoGen. There's a number of frameworks out there that ultimately help people build structure into their interactions, because in software agent might get a single request, but it might actually have to go back and forth to the language model to get to a plan that is executable, because the first iteration might only give a certain set of things, and then the second iteration might get to a more detailed. And that's all behind the scenes, so you don't see that, but that's really what the software part of the agent is, where you have to go and reason over, is the plan that I'm getting back already executable, and so forth. And then Eric called it the action layer. Most agent people actually call it tools. And these tools are effectively ways for the agent to get something done. The way I describe an agent, generally speaking, it's a brain on a stick. It doesn't have arms and legs. It doesn't know how to press buttons or get something done. It just doesn't. Because it has a reasoning environment, the language model. It has a plan that comes back out of the language model. And then it needs to say, okay, I'm supposed to go and shut that machine down, but I don't have any way to shut that down. So there has to be a tool that the agent has access to that effectively allows the agent to press that button. That could be, again, an automation environment, could be a normal database, could be an ERP system, whatever it might be, that is exposed in a way that the language model can understand it and reason over, when I see this thing, I need to press that button or call that API or use that resource to get my job done. So this combination between the model, knowledge, the software part with respect to iteration to get to the execution plan, and then the tools make the basic anatomy of a basic agent. This is what you need in order to get this done. And every agent is ultimately also a software service, which means there's an endpoint associated with that software agent, where you can either have an HTTP endpoint, or you might have an event endpoint, or might have both, where somebody says, I'm going to get a HTTP request, or I might send an event over an MQTT queue, or whatever you might use to effectively that software agent. And then the software agent gets the data it is supposed to act upon. It has its knowledge base built in. It has access to the language model, and it has access to tools that it is authorized to use. That's the basics. Now then we can go to fancy stuff. What you've seen now when you're looking into ChatGPT or M365 Copilot and those kind of tools, you see that there's now a thing called memory. Memory means that the system actually knows that Eric asked these 5 questions over the last day, or David, you had asked the system to do a number of things. And anytime you come back to that same conversation, it knows what you talked about. So it's effectively knowledge, but it's focused on that session, that interaction that you have with that agent. And then there's various types of knowledge. So you can have short-term memory, meaning the session memory. What we talked about in the last 10 minutes. Then you can have long-term memory, which is, hey, I'm storing everything that we ever talked about. So that's really what, when you're looking into the new ChatGPT or Copilot and stuff like that, that's what they do. And software agents will have the same thing, where they will know, okay, I executed this business process automatically. And here is what the decisions are that I made based upon what's going on. And I keep that. So that when I next see the same thing, I might draw on that my memory to keep the execution going. So that's already very fancy, but it's going to become a fairly common thing where we see people will build these kind of complex things. And then the next piece, obviously, is like, that's how you build an agent. Eric, I'll let you go and chime in, and then we'll talk a little about the governance part of the agent system, because agents shouldn't govern themselves, because they are semi-intelligent things. Again, they're not really intelligent, but they are reasoning and goal-seeking. So they might or might not understand that you try to constrain them. And therefore, governance is an outside thing from the agent itself.
Yeah,
Can I insert a brief thing in, Eric, before, because I really want to hear what you have to say. But I know that here at Microsoft we're acronym averse, and so I'm loath to bring in another acronym. But the other acronym that you'll hear a lot in this context is MCP, Model Control Protocol, right? And
we'll get there. Okay,
great. I just want to make sure that people are like, well, wait, I know something about MCP.
Yeah.
So
let's not forget A2A.
Right. So well, I tell you, if you want me to hang on that, Oli, I will. I just want to make sure that
hang on. We'll get there.
Okay, Eric, why don't you go?
No, I think Uli definitely adequately laid out, more than adequately laid out, the anatomy of an agent. And I think it's excellent. What the only tweaks I would have, or the maybe diving in a little bit, is to memory. And I think Uli, you started to talk about the different types of memory. So cognition tools, 100%, and then memory, I think, is what usually trips up architects. Because these things actually have, in my mind, 3 separate types of memory that agents need. And Uli, you talked a little bit about one, which is basically like working set memory. In my pass through the agent, these are the things that I need to store in my temporary RAM, my short-term memory about what I'm doing, just so I can keep track, especially if it's a multi-shot reasoning workload that I'm responsible for as an agent. I need some place to store working memory. The second one is what I call medium-term or episodic memory. So this is memory that says that, hey, for time-ordered trajectories that happened in between separate calls, I'm being rehydrated to do something or to think about something that happened before that I don't have context for, but I have to go and figure out what I did in the previous 10 executions, 15 executions, or whatever it is. So that's that medium-term memory, and things eventually will age out of that. The last is long-term memory, where I would also group the knowledge that Uli was talking about, standard operating procedures, any type of dictionaries or any type of knowledge. That usually fits there. It also, and again, this is typically RAG scope as well. So vector database sources, text documents, any type of knowledge source fits there, and anything else you want the agent to have as part of its area of expertise usually sits in that long-term memory. So that's kind of how I look at memory and how it's kind of utilized. And
I disagree a little bit with you, Eric, because I like your first two. I think those I agree with. Again, I simply said start with short and long-term memory, but I like the way you described it with more detail. But memory can become knowledge, but it can also not become knowledge, because knowledge means that any instance of the agent, any system can have access to this, again, based on authorization and authentication, all that other stuff.
Sure.
But it's generic knowledge. But in the session, in each session, you could have actually very sensitive information in there that should only be part of the agent interaction with the job that it's supposed to get done, and not become general knowledge or public or knowledge in general. So there has to be an explicit process from my perspective to take longer term memory and convert that into knowledge, because those are two different things. And there's lots of sensitivity that you potentially have to do. In the chat example, it's easy. If my boss Satya has sensitive information that he shares with its software agent, you don't necessarily want that knowledge, that memory, to become knowledge, which any chat could then draw upon. So that's where I would say we need to be thoughtful of how we think about long-term memory becoming knowledge. I think that has to be an explicit process from my perspective.
So can I ask a question that takes us in a slightly different direction? Are you cool with that, Eric? Unless you want to directly respond, because I have a question that you've now really brought to my mind based on this discussion.
Yeah, I do agree with Uli that that not everything that goes into the memory bank actually becomes part of this amorphous set of information that the agent should have ubiquitous access to and utilize in every transaction. There does have to be guardrails about the different types of memory, and in often terms in agent implementation, you will see these as separate repositories. One might be a graph database, the other one might be a vector database, one might be relational, one might be other machine learning models. And there should not be any permeability that's unintended between those sources. In addition, the one thing I will also note that Uli made me think of is the perception layer has to actually deal with PII minimization. It has to deal with cleaning data. It has to be able to make sure that when it receives data sets, that it doesn't know too much or retain too much or send too much of that information to the cognition layer. And then subsequently coming out, it also has to make sure that it's not telling things to other agents and or systems that it shouldn't know or maintain.
Okay, so this is what's interesting to me about this is much of what we're talking about here also gets you into all the broad category of problems called caching problems, right? When do you cache? How much do you cache? Who do who can see that cache, and et cetera. And so that's the way I think about it. What's interesting to me is I haven't heard anybody talk about the process or the best practices for how an agent is supposed to refresh its knowledge of the world. So let's assume you have an agent that's working on Azure and it makes stuff, right? And you're going to say, hey, make sure this is true in Azure. And then I'm going to rehydrate it or something. And it has to now go see what is true now. What is that? Where does that lie in this architecture, right? Like there's the looking back, but how do you handle the looking at what is and how often and whatever? It's yet another caching problem, right? Like this.
Yeah, David, I think it's an awesome one. So first of all, again, you have two sources or three sources actually that the system deals with. The first is data,
right?
So events, or it looks at a database or whatever it might do. But this is data. This is mostly input. Then you have knowledge, which is, again, data in itself, but it's stored in a different way. It's effectively an embedding so that the models can understand it, mostly stored in vector databases, but can be other sources as well. And then the last one is memory. And knowledge in general, what I would say, is being kept up to date. So in the Azure case, let's say you would be an agent that deals with Azure details. It's the documentation that gets vectorized.
Sure.
As embeddings and so forth, and that keeps being refreshed. So there's a process in there that the knowledge keeps being refreshed. If that doesn't happen, then the knowledge might become stale, and then the agent will act on old information. But that's then an enterprise failure from my perspective. The software agent can't do anything because it relies on the knowledge source to be up to date. So that's, for me, a process that you have to do and make sure that the content keeps being updated.
What's the environmental aspect that's interesting to me? Like I'm wondering about that. Like how does it keep aware of its environment, its current environment, which is different than how do we make sure that we're feeding the right knowledge in and updating as well, right? It's if it has to be environmentally responsive, how often does it get a chance to refresh its understanding of that environment?
Again,
well, maybe we could
doesn't do any of that. Sorry, Derek.
Well, maybe we could center on a specific example, Uli. I was thinking about, like, if I'm understanding your question, David, like if there's an update to policies, docs, FAQs, datas, APIs, how does the agent know that, oh, there's a new version of this out there? Is that kind of...
Well, it's more like, congratulations, I want my agent to be operating against Azure, right? Azure has resources. Now, not all the resources started on Azure by something will be started by the agent. And so it may have to periodically say what is true now, what is currently running, such that I may now, if I get asked a question, like make sure, is this true about my environment? Like I guess it can do that at evaluation time when it's trying to figure out if it's true. But I'm just trying to think about like how you handle the environmental knowledge of it. Or is your answer, as long as you've got a feed of data into it on a constant, on a real-time basis, that's the way it works. It never goes out and queries like, what's the world now? And now what's the world now? And now what's the world now?
It would have to explicitly, Eric, I haven't heard anybody trying to do that.
Okay,
it would have to be effectively using a RAG model where an explicit process goes and says the agent needs to know what the latest set of resources, to use your example, are. And therefore you have to feed it into the agent process as a knowledge piece.
Okay.
Yeah, well, I agree. I don't think an agent needs to know about where it lives, what service it lives in, all that stuff. I do think it cares about what's the knowledge now, and what do I need to do in order to get the latest information so that I can achieve my goals. So in a couple of agents that I've implemented, we set time to live expiration policies associated with authoritative knowledge sources that basically say, hey, if it's been over 2 weeks since you've looked at and cached this particular set of policies or FAQs, go back and actually make sure you refresh it during your next request. So that's marginally environmentally aware, but it doesn't know anything about the network compute and storage that it's operating on.
I mean, I was thinking more like in the babysitter model, right? Periodically, you want your babysitter checking in to see what the kids are doing, right? Like, and to act accordingly. Like, that's what I'm trying to say.
This is what I call agent ops.
That's it. Yeah, but that's a different conversation. So, one of the things you could do, is to say, hey, agent, as your first step in your goal seeking, and remember, this is not a single step process per se. You might say, actually, go ahead and refresh the knowledge base.
Okay.
Do a specific process, again, using tools or another agent that is actually the agent that goes and refreshes the software, the knowledge base that you have. All of that is feasible, but ultimately the software agent gets fed information from various sources, and it then acts upon it using the reasoning approach from the language model, and then builds a plan for execution.
Got it.
Ultimately what it does. The key thing that I think, David, you didn't let us go and get to is memory. And part of what's going to be interesting is these agents are not human beings, but they will run into similar issues like us when they rely too much on memory.
Right.
Because you have to have the ability to unlearn things. And we all know how hard that is. And so part of what we need to think through is when you start to introduce memory into your agents, you have to think about, how do I make sure that I don't box the agent into a knowledge environment, that they make decisions based upon what they've seen before. And what we want them to do is rethink what's going on.
You want to validate the cache, right?
You need to manage the memory.
Yeah, and validate the cache. Well, you said something before that I think we need to pick up on, because we started to say the ops letters were said, and you said governance, and how we actually run these things is clearly a topic. So how about the three of us agree that we're going to use that as the topic for the next episode? Are you all cool? We're going to talk about, like, how do you run this stuff, and how do you govern this stuff? If you're cool with that, then what I want to do is thank our architects, and I want to thank our audience for joining us. And I hope you'll be with us for the next episode of Armchair Architects as part of the Azure Essentials Show.